I'm gonna just log in quick. One of these commands over here. So, yeah, if you haven't completed the daily 5 assignment, that's the only one that's still open yet. So go ahead and submit that if you haven't completed it. Assignment, yeah. So I should say this quick. I did mess up the names, so I'll just submit to assignment or daily 4 instead of daily 5. Like I said on D2L News, I should be able to fix it on my end. Whenever you submit a file, it doesn't necessarily overwrite your old file. It saves it, and I can see all those too. So I should be able to fix it. If I'm in doubt, I'll just give you the points. It's 1 point. It doesn't really matter. But assignment 2 is due Sunday the 6th at 11:59 p.m. So really quick, we're going to talk about changing your password. So by default, your password, of course, is your student ID number. Not necessarily something you want to keep it as if you want to keep your account private, because your student ID number is not necessarily private. People can obtain your student ID number through various means. So I'm pretty sure I talked about this before, but if you want to change your password, you can do PASSWD. Type in your new password, or your current password, I guess. Type in your new password, and type in your new password. And since I didn't change my password, it'll say password unchanged. But if you put your old password for your current password, your desired password for new, and then retype it there, you can change your password to be more secure, etc., etc. So we're going to talk about return codes quick. Recall that we said we can open up. Doesn't necessarily matter what C file we open up. Literally open up anything. Recall that we were talking earlier about how main returns int, and the reason it does that is because when your program finishes, it needs to notify the operating system of how it ran, if it ran correctly, or if it ran abnormally, or had some sort of error. So remember that we can optionally put at the end of our program return. We can say return 1. We can say return 0. We can say return whatever. And by default, our program assumes that we're returning 0. 0 is the default. 0 means we ran well. So let's just say we're going to return 1. And again, we can compile that. And run it. And then we can use echo $? To see the return code from our program. Now, in the future, when we get into more complex programs, I just want you to keep that in mind, that we can view return codes and set them by saying return. And in other programs that you may find elsewhere, they're always going to have return 0 at the end. But at this point, compilers automatically know that if there's no return 0 at the end, that we're automatically adding that. But just something to keep in mind if you're looking at other programs. So we're going to start, I'm just going to run through everything we've talked about really quickly here, just to make sure that everyone knows what's going on. So we're doing day 7, day 6. So whenever we want to use functions like printf, puts, functions that, what we're going to talk about next week is functions that read from the terminal, but also what we're working on right now are functions that output to the terminal. When we want to use those functions, we include the header file stdio.h. And whenever we want to use functions like puts or printf, we need to use that. Now, we don't necessarily have to include that. Our program doesn't have to ever include standard or stdio. We can write a program that's like int main and then literally return 1. So if for some reason we don't want to do any I/O, we don't want to use printf or puts, we don't have to include that header file. It's completely optional. But in order to use those functions which perform I/O operations, we always need to include standard io.h. So talking about our main function, main is where our program execution starts. And everything inside these curly brackets is executed from top to bottom. The curly brackets I personally usually put them on the same line as int main parentheses, but you can also put them down here. it's typically recommended that whenever you're inside a function declaration like this, inside these curly brackets, that you indent whatever you're working on. You don't necessarily have to do that though. C doesn't really care. You could say this. You could tab it, or you could tab or space it out, or have it at any level of indentation. Now, this isn't necessarily good to do, but you could also have multiple statements on one line. You could do int a equals 1. You could do printf. You could put as many statements as you wanted to on one line. Now, the reason we don't do that is so your program is more readable, so we can start reading from top to bottom and see exactly what's going on. But notice, the only thing that actually delimitates the lines is the colon, or semicolon, I should say. So if you don't have a semicolon at the end of the line, your compiler is not going to know what's going on when you run GCC, and it's probably going to give an error. So just make sure you have that semicolon at the end of the line, because it's the only thing that delimitates the statements from each other. So we talked about the different types of variables that we can declare. We can declare an integer, a whole number, a floating point number, a decimal number, a character, which is any letter you can type in on the keyboard, enclosed in single quotation marks. Now, so an integer, you'd say int. Floating point number, you'd say float. Char, you'd say char. And you can give it any name you want to. I believe you have to start. I believe you can't have special characters in the names, actually. The only special character you can use is underscore, I think. But you can't do something like my variable. Those, you have to have all characters together. You have to say like my underscore variable. So just say k or a equals this. Remember that anything it's a character is a single character that you can type on the keyboard enclosed in single quotations. And we'll say int b equals 10. And remember, an integer is a whole number. And then float c equals 10.1. Let's make it a little more unique and say 30.3. And remember that when we output a floating point number, by default, there's 6 decimal places to the right of the period. And at some points in time, when you output a floating point number or store a floating point number, the last few decimal places may change on their own, just because of the way that computers represent floating point numbers. So if you do see changes in, let's say, the 5th or 6th decimal place, that's completely normal, and you shouldn't be worried. And if you're ever asked what it'll output, just assume, if you're ever asked on a, let's say, quiz, what it will output, then you would just give it 6. Make sure you have 6 decimal places to the right of the decimal place, and make sure they're all zeros. They could be other numbers under certain circumstances, but assume that they're going to be zeros to the right of the decimal place. So just to review a few more things. When we're writing printf, we can specify our format string as the first argument to printf. We call the different things we give to a function arguments. So let's say we're using puts to output a single string. It takes one argument, which is a string. Now, if we had an arbitrary function that we were calling, an arbitrary thing that we were calling, let's say we have a function called function. Doesn't matter at all. We're not worried about that because function doesn't perform any function. It's not even usable. It's just something that we can say that's a function. But a function can accept a number of arguments depending on what it does. We can provide it literal arguments like that, where we specify the value in line, or we can give it a variable name, which will essentially, well, it gives the value based on what the variable currently contains. Now, all we have to remember about function arguments is that they're separated by commas. So we can say, if for instance, arbitrary function wanted a, b, and c, we just give it a, b, and c, and we'd separate it all by commas. But going back to printf, we know that printf, the first argument it accepts is our format string. And again, strings are enclosed in double quotations. So we want to go into our string and write exactly how we want the numbers outputted. We can do percent. Let's output exactly what we've declared up above. We can do percent %c for our character. We can do percent %i for our integer and percent %f for our floating point number. And you probably have already caught on to this by now, but you can see that the first letter of the variable is actually, or the data type I should say, is actually our letter that we use for our format specifier. So char, the first letter is C, int, the first letter is I, and F, or float, the first letter is F. Yes.
So is that how we're supposed to do the assignment for assignment 2?
I don't know.
You said you didn't like that.
I didn't like what?
Us doing it like that, as opposed to using the floats.
The floats?
Yeah, I wrote down like a good 30 printfs.
You should have a significant number of printfs on assignment 2.
Yeah, so that looks a lot easier.
Yeah, I mean, if you it doesn't matter at all. You can put multiple format specifiers in your string. But what you shouldn't do, you could do something like this. You could write your entire assignment in one printf. Now, I'm probably not going to be too happy about that because I have to go through and manually dissect the format string in my head. I mean, you could write this. You could write that and everything on one line. And this would probably, and I believe this would output, it would output A10 30.3 456, and then okay, we had that new line /n in there, and it would output again this line. It would just output it again because we haven't changed those values. And you could do that, but it'd make me mad. So going back and talking about printf, again really quick. So it's important that we match our format specifier with the data type of our variable. So if I was to go B, C, and then A, those aren't matching up. So when printf interprets the first argument you give to it, the format string, it's going to come up with %c first. And it's going to look to the right of the format string after the comma-separated values, and it's going to look at the first argument it sees to be a character. It's going to look for B to be a character right here. And since B isn't a character, it's going to crash hard. It's probably going to say segmentation fault or something like that. You need to make sure that the format specifiers you're using match up to the data type that you've defined. So in order to correct this, we need to say A, B, C. And then again, so C will be replaced by A, I will be replaced by 10, and F will be replaced by 30.3. Really quick, we can also say, let me see here what time it is. We can also, working with variables, we can also give them new values after we've used them. We can go up. We can give variables new values anywhere in our code. We can say A equals C. We can say A equals D. We don't necessarily have to use those values, but just so you know, you can give variables values with variable name, equal sign, and then value. And you can do that anytime in your code, as many times as you want to. So that's about all I have for review right now. Was there any other questions on what we've worked on so far? All right.
Like when you just did, you can use that to change variables. Like let's say you're for the assignment, you do that first half, and then you want us to change your variables.
Yes.
We can do it that way.
Yeah, exactly.
So
yeah, definitely. And so we'll talk about the assignment a little more in a bit. But so yeah, we can see. I should also talk about this. When we declare the variable for the first time that we see the variable name in our code, we have to give it we have to declare it with a data type. We have to say what type of data will it be storing. So when we say char A, that means that A, the variable described by the letter A, I should give these more descriptive names because my char. So whenever I refer to my char, that means I can only store a character value inside of it. And when I refer to my int, that means I can only, and say int my int, that means that I can only store integers, whole numbers inside of my int. And the same for C. So make sure that the data type you're defining the variable with matches the data that you want to try and put inside of it. So going back and saying, yeah, and at any point in the code, we can say our variable name equals whatever value you want to put inside of that variable. So then, something along the lines of this for the assignment. You declare your however many variables you have. You print out all of the variables with 3 printfs, I think. You have a bunch of reassignment statements to change the values, and you'd say printf n number of times. So on the note of the assignment, we're going to just go through and I'm going to talk about it one more time. If anything seems fuzzy, just ask and we'll try and sort out the issues. So the assignment will be submitted on dev.dusunix.net. It's the environment we've been working on so far. Do submit space assignment whatever your name is .c, and then enter the number that's displayed on the list. It should be like 3 or 4 by now. And then we want to perform the following functions. We want to declare and assign 3 integers, 3 floating point numbers, and 3 characters. So recall that declaring variables is a lot like this. Wrong there. So we want to declare variables just like this up at the top of our main block. If you don't declare variables for some reason, but are still using printf, I'm probably going to take off 2 points or so. I've seen that in the preliminary submission. So we want to output 1 variable of each type on a line 3 times. So we're going to have a total of 9 variables. So pick one integer, 1 floating point number, and 1 character, and output them on a line. Then remove those variables that you just picked from your group. Then select 3 more, remove those from the group, select 3 more, and then remove those from the group. When I say remove those from the group, I mean that your output should be unique. You shouldn't declare 3 variables and then output all, or you shouldn't declare 1 variable of each type and then just output those 3 variables every single time. You should have 3 variables of each type, and you should output each of them once. Does that make sense? A little bit, maybe?
Like this.
So like this. Yeah, that looks good, actually. I mean, your print, like it doesn't necessarily matter for me. You could write all your printfs on. You could write one format. You could write 1 format string for this component, this component, this component. Or I mean, you could by all means do this. You could write a format string just for A. I mean, a printf and an associated format string just for A, and just for 10, and just for 10.10. And then you could put your /n at the very last printf. That could be 3 printfs. It could be 1 printf. This entire first block could be, I don't know why you want to do this, because essentially when you write the format string for the first one, you just copy it down to the second and the third ones, and you replace the variable names at the end of the, in the comma list of the printf. And then we're going to, so that's our first block. We output 1 character, 1 integer, and 1 floating point number. Our second block, our second component of our first block, I should say, is outputting our 3 characters, our 3 integers, and our 3 floating point numbers. And then, and then in this space right here in your code, it's not visible here, of course, because this is the output. Take those variable names that you declared at the top and reassign them all different values, and then output them just the same as you did up above. So as of right now, is there any questions about how I want you to perform assignment 2? All right then. I think it's surprise time then. So, as some of you might have figured out, we have a quiz today.
Wait, no resources?
So for the first so there's 15 total minutes to complete the quiz. And for the first 10 minutes, I'm going to ask that you just leave D2L open in your web browser and don't navigate anywhere else or look at anything else or ask anybody else. So for the last 5 minutes, You can work together. You can look at dev.dscenics. You can look at any notes you've taken and just shore up what you're working on. So we're going to start at 11:24. So that means at 11:34, you can start to use the resources.
It's not easy enough.
Yes, so I will open it up in just one moment.
Alright.
So, and then as it says, after completing, you should work on assignment 2 and stick around if you're not done with that or have any questions, because this will probably be the last time I'll be available to help you with assignment 2 before it's due on Sunday. It's not active yet. Give me one moment, please.
Okay. Starting.
Hey, if you're starting late, you get more time, so. All right, your quiz is up. Please begin.